Good morning, everyone. This video is made for September 3rd, Thursday morning class. We are starting chapter 3. Plan to finish section 3.1 today. 3.1 linear equations in two variables and rectangular coordinate system. Let's start from rectangular coordinate system. If we have a horizontal scale like this one, we have a horizontal scale, and this is a positive direction, this is a negative direction, and this is a vertical scale, vertical real number line. This is a positive, this is a negative. We call the horizontal scale x-axis, the vertical scale y-axis. The two scales cross at 0, and we call the point origin. This x-axis, y-axis, and origin give us a rectangular coordinate system. And this coordinate system is a two-dimensional space. It includes all the points on the plane, not the aircraft, I mean the surface plane. For convenience, we divided the whole two-dimensional space into 4 parts. This is part 1. This is part 2. We follow the counterclockwise. This is part 3. This is part 4. Part 1 we call part 1 quadrant 1. Quadrant 1. And this is quadrant 2. This is quadrant 3. And the right bottom, that part is quadrant 4. How many points on the plane in a two-dimensional space in a rectangular coordinate system? We can see there are infinitely many, uncountably many points on in a two-dimensional space. For example, this is a point, right? In quadrant 1. This is another point in quadrant 2. This one in quadrant 3. This one in quadrant 4. We can plot many points. And this point does not belong to any quadrant. It's on the x-axis. And this point doesn't belong to any quadrant. It's on the y-axis. We define points, those points, in a rectangular coordinate system by an ordered number pair. We define the points on the plane in a rectangular coordinate system by an ordered number pair. Ordered number pair. We use a parenthesis to frame the two numbers. A pair has 2 components, right? The first component, if we say A, it's a number. Could be any real number. The second component, let's say B, another number, could be any real number. We use the comma to separate them. And this notation represents an ordered number pair. It describes a point on the plane, a point in a rectangular coordinate system. The first component is called the x-coordinate. The second component is called the y-coordinate. The x-coordinate describes the horizontal displacement of the point that is represented by the ordered number pair. The y-coordinate describes the vertical displacement of the point. For example, let's say we have 2, 3. This is an ordered number pair. It corresponds to a point in the rectangular coordinate system. The x-coordinate is 2. Remember, x-coordinate describes the horizontal displacement of the point. It is 2. It means the point is 2 units to the right of the origin. Yeah, the origin is our reference. Origin here is our reference. So the point is 2 units to the right because it's positive. If it's negative, then that's to the left, right? Positive is to the right, 2 units to the right. The y-coordinate instead describes the vertical displacement. It is I want to say -3. So sorry. So -3. Let's say the y-coordinate is -3. Means this point is 3 units below. If it's positive, it's above. If it's negative, it's below. 3 units below. 1, 2, 3. So think about the two components describe the location of the point. The point is 2 units to the right of the origin, 3 units below the origin. 2 units to the right of the origin, 3 units below the origin. So where do you think the point is supposed to be? This point, right? Yeah, this point is defined by this ordered number pair, 2, -3. 2, -3. There is a rule or pattern. Any points in quadrant 1, has both x-coordinate, y-coordinate positive. And any point in quadrant 2 always have a negative x-coordinate, positive y-coordinate. Why? Because any point in quadrant 2 would be to the left of the origin, above the origin, right? So x-coordinate is negative, y-coordinate is positive. Any point in quadrant 3, both of the two coordinates negative because it's to the left and below the origin. Any point in quadrant 4 has positive x-coordinate, negative y-coordinate, like the one we just dealt with, 2, -3. X-coordinate is positive, y-coordinate is negative, so it's to the right and below. That would make the point has to fall in quadrant 4. Okay? For the point on the x-axis, the y-coordinate is always 0. For example, this one, 1, 2, 3, 4. It is 4 units to the right, so x-coordinate is 4. It's not above, it's not below. You see, vertically, this point is at the same level with the origin, right? So the y-axis, y-coordinate is 0. So here we have a fact. Any points on the x-axis has a y-coordinate 0. And any point on the y-axis has x-coordinate 0. Y-coordinate depends on is the point below or above the origin. In this case, we have -3 because it's 3 units below the origin. Horizontally, this point is not to the left, not to the right, right? At the same level. So you might want to write it down. Points on the x-axis have y-coordinate equals 0. Points on the y-axis have x coordinate equals 0. Let me say that again. Any points on the horizontal scale, x-axis, their y coordinates always 0. Any points on the y-axis, the vertical scale, their x coordinates always 0. Okay? And what happened to this special point, this origin? What is the number pair that could define that point? It is 0, 0. 0, 0 corresponds to 0, the origin here. I think the best way to learn is to practice. Let's look at the example 1. Earlier we covered quadrant. We have 4 quadrants, right? Counterclockwise. And we talk about any point in the rectangular coordinate system is defined by an ordered number pair. If we are given some ordered number pair, like example 1, we need to plot their corresponding points. And what should we do? Let's see. Firstly, draw a rectangular coordinate system. Horizontal scale, vertical scale. This is x-axis, that is y-axis. This is the origin. Order the number pair A, -3, 1. X coordinate is -3. Y coordinate is 1. Give me 1 second, let me. X coordinate is -3, Y coordinate is +1. So the point is to the left, 3 units to the left, 1 unit above. And we have that point right here in quadrant 2. Okay? 3 units to the left, 1 unit above. That gives us this point. Let's see the second point, point B. Point B is -2, -2. X equals -2, Y equals -2. It is in quadrant 3 because it's 2 units to the left, 2 units below. You can repeat the video and figure out what's going on here. 2 units to the left, 2 units below. So that point is B. This is A, this is B, right? C. X coordinate is 0. Y coordinate is -5. X coordinate is 0 means the point is not in any quadrant. It is on the y-axis. Y-axis, 5 units below. 1, 2, 3. 1, 2, 3, 4, 5. So 5 units below. This point is C. 0, -5. D. X coordinate is 1. Y coordinate is 4. It's in quadrant 1 because it is 1 unit to the right, 4 units above. 1, 2, 3, 4. 1, 2, 3, 4. So the point is right here. You see the point is uniquely determined by the 2 components, the ordered number pair, right? E, 0, 0. 0, 0, we know that point is the origin, right? 0, 0. The point is the origin. This is E. F, 0, 2. X coordinate is 0. So point F is on the y-axis, 2 units above the origin. It is right here. Let's wait a little bit. Two units above the origin, that is F. G, -1, 0. This point has X coordinate -1, Y coordinate 0. So the point is supposed to be on X-axis. X coordinate is -1, so it's 1 unit to the left. G. Okay? So do you think you can do that? One more thing I want to point out is a point in a rectangular coordinate system is determined by, or is defined by an ordered number pair. Y is an ordered number pair. For example, 2, 5 and 5, 2. Both two pairs contain 2 and 5 as the components, right? But the order of the two components is different. The first one is 2, 5. The second one is 5, 2. Let's see, how do they represent two different points in a rectangular coordinate system? This one, 2, 5. X value is 2, Y value is 5. So it is to the right, 2 units to the right, 5 units above. 1, 2, 3, 4, 5. This point, the black point is 2, 5. And what about 5, 2? 5, 2 has the X coordinate 5. Y coordinates is 2, right? It's different. So X coordinate describes the horizontal displacement. Vertical, Y coordinate describes the vertical displacement. So that point is 5 units to the right. 5 units to the right. 1, 2, 3, 4, 5. 2 units above. It's right here. That is 5, 2. They are different, right? That's the reason ordered is a keyword when we talk about a point in a rectangular coordinate system. The fact is, there is a one-to-one correspondence relationship between ordered number pairs and the points in a two-dimensional space. It means any ordered number pair, for any ordered number pair, there's only one, not more, not less, exactly one point corresponds to it in a rectangular coordinate system. Vice versa, for any given point on the plane in a rectangular coordinate system, there's only one ordered number pair corresponds to it. One-to-one correspondence relationship. We actually mentioned, we actually had a one-to-one correspondence relationship before when we talk about real number line. We said any real numbers in a real number set and a point on the real number line, we have a one-to-one correspondence relationship between them. We have a one-to-one correspondence relationship between the real numbers in the real number line and the points on the, we have a one-to-one correspondence between real numbers in the real number set and the points in the, on the real number line. For any real number, there's one point corresponds to it. For any point on the line, there's only one real number, make a pair with it. So actually, this conclusion is a generalization for this conclusion. I want you please look at them together, understand them together, see the similarity, see the pattern. Because there's a one-to-one correspondence between ordered number pairs and the points in the two-dimensional space, we normally do not make a difference between the two things. When we see a point on the plane, we know that is an ordered number pair. When we see an ordered number pair, we know, okay, that is a point on the plane, two-dimensional space, a surface. Okay, so please repeat this part. Really understand the concept of rectangular coordinate system. Well, I have to apologize for my enunciation today because I'm having my retainers on. I'm supposed to wear it right now, so sorry about that. Now let's move to the next topic. We're gonna see how do we define a linear equation in two variables. In previous chapter, chapter 2, our focus was linear equation in one variable. In this chapter, chapter 3, we talk about linear equation in two variables. Well, first thing we need to know, so this is a new friend, right? We need to know, what does the new friend look like? It looks like this. Any equation which can be written in the form ax plus by equals c is a linear equation in two variables. And we call this equation the standard form of a linear equation in two variables. Let me explain. How do we determine a given equation and given equation is a linear equation in two variables? If the equation satisfies the following three criteria, then the equation would be a linear equation in two variables. Let's just fill the name. Equation. Firstly, you see equality symbol, right? Secondly, you see two variables. By the way, A and B are numbers. A, B, C are numbers. A and B are coefficients of the two variables. A is the coefficient of x, B is the coefficient of y. A and B cannot both be zero. Yeah, this is a very important condition. We will spend time to detail on that. A and B are not both zero. That means one is a zero, the other is a non-zero. That is okay, right? A is the coefficient of x, B is the coefficient of y, C is the constant on the right-hand side of the equation. A and B are not both zero. So you have two variables, x and y. That's the second criteria. Number 3, if you see the variable appears, the power on the shoulder of the variable always 1, means you don't see square, you don't see cube, you don't see -1 power. The power on the shoulder of the variable is always 1. Those three criteria can help you to determine if an equation, a linear equation in two variables or not. Yeah, so let's see. We have the following 6 examples. Example 1. Example 1, we have the 6 equations. We need to determine, are they linear equation in two variables or not? Yeah, example 1 is to help us understand the definition of linear equation in two variables. Example 1 is to help us to determine. Example 1 is to determine if a given equation, linear equation in two variables or not. So it covers the definition of the equation. Number 1, 3x plus 4y equals 9. It is a linear equation in two variables because you see equation, you see two variables, and it's linear. You see what I'm saying? Also, by the definition, this equation is already in the standard form. The standard form is ax plus by equals c, right? Anybody can tell me what is a, what is b, what is c? A is the coefficient of x, b is the coefficient of y, c is the constant on the right hand side of the equation. Can you see that? That's number 1. Number 2, x minus y equals 0. It is a linear equation in two variables because it's in the standard form of a linear equation in two variables. A is 1. It is the coefficient of the variable x. B is negative 1. It is the coefficient of the variable y. C is 0. It's the constant on the right of the equation. Number 3, x plus 2y equals negative 8. Compare this equation with the standard form. You know, number 3 is also a linear equation in two variables, and it's in the standard form already. It's in the standard form already. And what is A, what is B, what is C? A is the coefficient of x, so it's 1. B is the coefficient of y, so it's 2. C is the constant on the right-hand side of the equation. It is negative 8. Number 4, (3x) equals 6 minus 2y. 3x equals 6 minus 2y. Well, this equation is not in the standard form because in the standard form, both variables are on the left. On the right, we only have the constant term. Number 4, at least, is not in the standard form, right? Let's see if we can rewrite the equation in the standard form. I'm going to move that term over. I am going to move that term, negative 2y, over. Remember my transposition of terms, the technique. So I copy 3x. I move negative 2y over. Remember, move it and change the sign. We have a plus 2y on the left. What happened is I moved the term negative 2y over. It becomes positive 2y on the left. On the right, we have 6. Well, now look at it again. Do we have the equation in the standard form now? A, B, C. A is the coefficient of x, which is 3. B, coefficient of y, 2. C, constant term on the right-hand side, 6. Right? Number 5. Number 5, x equals 4. I believe your first reaction might be, well, this is not a linear equation in two variables because you only see one variable x. Y is not there, right? However, this equation is also a linear equation in two variables because the equation could be written in the form ax plus by equals c. Let me show you. We have x plus 0 times y equals 4. The coefficient of x is 1. So A is 0, A is 1, A is 1. Coefficient of Y is 0, so B is 0. C is 4, right? A and B not both be 0, because A is non-zero, B is 0. So number 5, this is a very special thing. You don't see variable Y is because the coefficient of a variable Y is 0. That is still, the equation is still a linear equation in two variables. I hope you can repeat this part to really understand that. By the definition, the equation could be written in the form ax plus by equals c. So by the definition, x equals 4 is a linear equation in two variables. Number 6, y equals -5. This equation is also a linear equation in two variables because we are able to write that equation in the form 0 times y. Let's do x first. 0 times x. 0 times x plus 1 times y, which is just y, right? 1 times y is y. 1 times y is y, equals -5. It is in the form of the standard. It is in the form of ax plus by equals c, where a is 0, b is 1, c is -5, right? By the definition, number 6 is also a linear equation in two variables. Is also a linear equation in two variables. Example 2. Through example 2, I want to explain how do we define a solution. How do we define a solution of a linear equation in two variables? We have the definition for the solution right here. If we have an ordered number pair a comma b, and x equals a and y equals b satisfy the equation, then we say a comma b is a solution of the linear equation in two variables. Because linear equation in two variables involve two variables, x and y, its solution, if it has any, must be an ordered number pair. The value for x is the first component. Value of y is the second component. Let's look at the example 2. The equation that we have here is x minus 2y equals 8. I want you to help me to determine if 0, 0 is a solution of the equation or not. How do we know that? We plug in x equals 0, y equals 0. If we get a true statement, then 0, 0 is a solution. Otherwise, if we got a contradiction, then 0, 0 is not a solution. It is a very straightforward process. We plug in x equals 0, y equals 0. We plug x equals 0, y equals 0 into the equation. So I use parentheses to hold the place. We put a 0 in the place of x, put a 0 in the place of y. We have 0 minus 0 because anything times 0 is 0, right? So we have 0 on the left, 8 on the right. Obviously, this is a contradiction. That means 0, 0 does not satisfy the equation. 0, 0 is not a solution. Is not a solution. And this time, I'm going to change a different point. Let's try another point. This time we try 0, -4. we determine if 0, -4 a solution of the equation or not. Then we plug in x equals 0, y equals -4 to see if we have a true statement or contradiction. We put 0 in the place of x. We put a -4 in the place of y. -2 times -4, we have 8. That is a true statement. It means 0, -4 is a solution of the equation by the definition below it. Okay? Here we have a problem. How many solutions do you think the equation have? The answer is it has infinitely many solutions. Why is that? Because you have two variables. Whenever you give one variable a fixed value, you are able to solve for the other variable. And then you would have a ordered number pair. And that ordered number pair is a solution of the equation. For example, if you let x be 1, you can give x any numbers. You can let x be 0 or 1 or half or -3, pi or -1 million. You give x a given number, a fixed number, and you plug in x equals 1, then you would have 1 minus 2y equals 8, right? So once you give x a fixed value, the equation would only contain variable y. And you always could solve the equation for y to get the value of y. In this case, we have 1 minus 2y equals 8. Bring 1 over, we have -2y equals 7. 8 minus 1 is 7. Divide both sides by -2. We have y equals -7/2. So it means as x equals 1, y equals -7/2. That is an ordered number pair. First component is the value of x. Second component, value of y. That ordered number pair is a solution of the equation. So whenever you give x a value, you could always solve for the corresponding y. You would have a solution, right? So you can see from here, the equation has infinitely many solutions. It's true for y as well. I mean, if you give y a value, any value, for example, you let y be 0, you could always solve for the corresponding x, and you would have an unordered number pair, right? And that ordered number pair is the solution of the equation. For example, if you let y be 0, you have x minus 2 times 0. The equation only contains x, one variable, and you solve for x, you have x equals 8. X equals 8, y equals 0. That gives you an ordered number pair. First component is the value for x. Second component, value for y. That is a solution of the equation. So my point here is to show you linear equation in two variables has infinitely many solutions. Infinitely many solutions. Another point of example 2 is to practice for given value of x or y. How do we solve for the value of the other variable? So we're going to complete this table. This means for this equation, x minus 2y equals 8. If you let x be 0, what's the corresponding y? The pink part, if you let x be 10, what's the corresponding y? The yellow part, if you let y be 0, what's the corresponding x? The green part, if you let y be -2, what's the corresponding x value? So let's see how do we do that. Number 1, we let x be 0. So we plug in x equals 0. 0 minus 2y equals 8. So that is negative 2y equals 8. Divide both sides by negative 2. Y equals negative 4, right? So the corresponding y value is negative 4. We have a completed ordered number pair now, 0, negative 4. That is the solution of the equation, by the way. 0, negative 4 is the solution of the equation. If you plug in x equals 0, y equals negative 4, it satisfies the equation. Let's see number 2, the pink. We let x be 10. We replace x with 10. 10 minus 2y equals 8. Move 10 over, a minus 10. Negative 2y equals negative 2. A minus 10 is negative 2, right? Divide both sides by negative 2. We have a y equals 1. Y equals 1. So the ordered pair here is 10, 1. We got another solution. 10, 1. X is 10. Y is 1. That's another solution. Number 3. This time, the value of y is given. We need to solve for x. So we let y be 0, the yellow part. We let y be 0. Let's plug in y equals 0. We have x minus 2 times 0 equals 8. That is x, this part is 0. This part is 0. Oops. Negative 2 times 0 is 0, right? So we have x equals 8. We have x equals 8. And we got another solution. X is 8, y is 0. The first component always x coordinate. Second component is always y value. Number 4. We are given the value for y. This time y is negative 2. We need to find the corresponding x value. We plug in y equals negative 2. X minus 2 times y. Y is negative 2, so we put it here. Negative 2 times negative 2 is 4 equals 8. We move 4 over, change the sign, a minus 2, 4. We have x equals 4, right? We have x equals 4. So that's another solution, 4, negative 2. Yeah, this example shows you how do you complete ordered number pairs satisfy the equation. Is one way to find the solutions for a linear equation in two variables. And now we are going to plot those points. Let's see what will happen, okay? So now we are going to plot all the 4 solutions of the equation on the same rectangular coordinate system. We just covered the definition of rectangular coordinate system. 0, negative 4. 0, negative 4 is on the y-axis 4 units below. Okay, this point. 10, 1. 10, 1. 10 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1 unit above. So this point is 10, 1. Okay, 10 units to the right, 1 unit above. Number 3, 8, 0. It is on the x-axis. 8 units to the right on the x-axis. So 1, 2, 3, 4, 1, 2, 3, 4 is right here. That's 8, 0. Number 4, the last one, the green one, 4, negative 2. 4 units to the right, 2 units below. 4 units, 1, 2, 3, 4, 1, 2. Okay, So what do you see, the 4 points? Do you see them? Do you see that they are collinear? Collinear. Collinear means they are on the same straight line. Right? They are on the same straight line. And this is not a coincidence. This is not a coincidence. Remember, we agree this equation, linear equation in two variables, has infinitely many solutions. If you have the time to plot more solutions, you will see they are all collinear. And the straight line passing them is the graph of the linear equation in two variables, x minus 2y equals 8. In fact, any linear equation in two variables is a straight line on the plane. Okay? Any linear equation in two variables is a straight line on the plane in a rectangular coordinate system. This is just one example. And what's the connection between linear equation in two variables and straight lines? I want you to please understand those three things. We have a one-to-one correspondence between linear equation in two variables and straight lines. What does that mean? Means any linear equation in two variables. For any linear equation in two variables, there's one straight line corresponds to it. Vice versa. Any straight line, for any straight line on the plane, you can draw any lines, right? You can draw a line like this. Hold on. You can draw a line like this or this, right? You can draw many lines. For any of those lines, there is exactly one linear equation in two variables. Make a pair with it. There is a one-to-one correspondence between the two things. They are actually is the same thing in different forms. Linear equations in two variables is the algebraic form of a straight line. A straight line is the graphical form, geometrical form of the linear equation in two variables. Earlier we have agreed there is a one-to-one correspondence between ordered number pair and the points, right? If we put them together, if an ordered number pair is a solution of a linear equation in two variables, that means the point a comma b is a point also, right? Ax plus by equals c is a straight line. The point a comma b is on the line ax plus by equals c. So I want you to please repeat this part to really see those three things here. Very important to understand. Straight lines are the geometric form of linear equations in two variables. Linear equations in two variables are the algebraic form of straight lines. They are the same thing in two different forms. Okay, so in the graph you are looking at it right now, there are 2 points kind of special. This one and this one. Let me see, this one is 0, -4. This black point is 8.0. The reason they are special because look at 0, -4. 0, -4 is the intersection. Of the straight line and the y-axis. So we call 0, -4 y-intercept of the line or the equation. They are the same thing, remember. And look at the a, 0. This point. Is this point the intersection of the straight line in black and the x-axis, the horizontal scale. We call that point the x-intercept. Two very important concepts. Intercept of the line. Okay? Yeah, simply put, x-intercept is the point where the straight line cross x-axis. Y-intercept is the point where the straight line cross the y-axis. The formal definition is right here. X-intercept of a straight line is the intersection of the line and the x-axis. Y-intercept of a line is the intersection of the straight line and the y-axis. Okay? So let's see, how do we find x-intercept and y-intercept for a given straight line? How do we find x-intercept and y-intercept for a given straight line? We are going to take number 3 as example to explain the process. X plus 2y equals -8. We are going to find the x-intercept and the y-intercept for this straight line. It's a linear equation in two variables. This is how we do that. Let me write solution. In order to find the x-intercept, we make y be 0. Yeah, we plug in y equals 0. Let's see what we have. X plus 2 times 0 equals -8. And we have x plus 0 equals -8. And x equals -8, right? So -8 comma 0 is the x-intercept. Let me repeat it. In order to find the x-intercept, we make y be 0 to solve for x. And then you would have value of x, you have a value of y, and that gives you an ordered number pair. And that ordered number pair is the x-intercept of the equation, okay? How do we find y-intercept? In order to find the y-intercept, we make x be 0. Let's see what do we have if x is 0 in the equation. X is 0 plus 2 times y equals -8. So 2y equals -8. Divide both sides by 2. We have y equals -4. You see, when we make x be 0, we have the corresponding y, right? We have a pair. Ordered pair. You're gonna always put x coordinate the first component, y coordinate the second component. So that is this ordered number pair. That point is the y-intercept of the line. Okay, so this is how we find the x-intercept and the y-intercept. This is how do we find the x-intercept and the y-intercept. The last part of this video, we are going to look at 4 and 5. We are going to look at 4 and 5. 4 is x equals 2. We have agreed this equation is also a linear equation in two variables because it could be written as 1 times x plus 0 times y equals 2, right? A is 1, B is 0, C is 2. By the way, watching the video one time is not enough, far less than enough. It's better you can watch like a few times to really understand the concepts. Yeah, so x equals 2 is a linear equation in two variables. Is a linear equation in two variables So it is a straight line as well. Well, what a kind of straight line? What a kind of straight line? Let's find some solutions. Let's find some solutions for the straight line, for the equation. Because the coefficient of y is 0, really doesn't matter what's the value of y equal to, right? It could be 1, could be 0, could be 100, could be negative 100, right? Doesn't matter. So for example, we let y be 1, then x is always 2. So I hope you can see this. No matter what value of y is equal to, no matter what value of y, the value of x is always 2. It's always 2, right? You can let y be 5 or 10. X is always 2. So if we graph those points on the in a rectangular coordinate system, we have 2, 0, 2, 1, 2, 1, 2, 1, 2 units to the right, 1 units above. We have this point. 2, 0 here. 2, negative 1 is here. 2, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5 is right here. Do you see the 4 points? You can actually find more. The 4 points are collinear. If you connect them, you have a vertical straight line. Okay? So here we have a conclusion. If in a linear equation in 2 variables, variable y is absent, then the linear equation in 2 variables is a vertical straight line. Please repeat this part to really get it. Number 5, we have equation y equals -5. We explained earlier, this equation is also a linear equation in 2 variables with the coefficient of x equals 0. So this equation is also a straight line. It's also a straight line. What kind of straight line? Let's find some solutions. As you see, the coefficient of x is 0. So x could be any number. If you let x be -1, 0, or 5, or 7, it doesn't matter what the value of x equals. Y is always -5, right? Yeah. No matter what x equal to, y is always -5. If we plot them in the same rectangular coordinate system, let's see, what would we have? -1, -5. So to the left 1 unit, below, go down 5 units. This 1 unit to the left of the origin, 1, 2, 3, 4, 5. 5 units below. So this is -1, -5, right? And 0, -5 is this one. 5, -5 is here. 7, -5 is here. So did you see all those points are collinear as well? And they gave us a horizontal straight line. The horizontal straight line represents the linear equation in 2 variables, y equals -5. So here we have a conclusion. If we have a linear equation in 2 variables with x absent, you don't see x, you only see y, then the linear equation in 2 variables gives you a horizontal straight line. Please repeat this part and really understand it. For the vertical straight line, could anyone tell me what's the x-intercept? What's the y-intercept? Yeah, look at the orange straight line. It is a vertical. Yeah, for the vertical straight line, what's the x-intercept? This case is 2, 0, right? Yeah, that's the intersection of the vertical line and the x-axis. And what about y-intercept? Does not exist because vertical straight line does not cross y-axis. It is parallel. Two parallel straight line do not cross. Let's see horizontal straight line. In our case, it's y equals -5. This black horizontal straight line. Let's see what's the x-intercept of the line and what's the y-intercept of the line. X-intercept of the horizontal line does not exist because the horizontal line is parallel to the x-axis. It doesn't cross. Y-intercept of the horizontal line, in this case, is 0, -5. This point. That's the intersection of the black horizontal line and the y-axis, so 0, -5. And this video covers all the things that you need to know about section 3.1, linear equation in two variables, from the rectangular coordinate system to the definition of linear equation in two variables, and to the geometric significance of linear equation in two variables. Linear equations in two variables are straight line. And then we also covered how do we define a solution for a linear equation in two variables, and how do we find the x-intercept and the y-intercept for linear equation in two variables. Thank you guys for watching. I hope you can watch this video September 3rd on Thursday, because on Friday we will have a new content. We will cover new content. So please watch this video on September 3rd, Thursday.